Today's topic is circle analytical geometry. So as I'm sure most of you are aware by now, this is in paper 2. And the way that your paper 2 paper is going to be structured is the first questions that you're going to get. So probably question 1, question 2, these will be questions on statistics. And then generally question 3 is a question on grade 11, analytical geometry. And then generally speaking, question 4 is a question on circle analytical geometry, which is the grade 12 analytical geometry. All right. After this, we move into questions 5 all the way through to about question 11. And then this is where we start doing our trig and then our Euclidean geometry. So really the way that it works is that we want to try and get as many of the marks as we possibly can in the statistics section. In fact, we want to try and get full marks for that. We also want to try and get full marks in the analytical geometry section. So circle analytical geometry comes before trig because a lot of people find it easier than trig. But there can be difficult questions and they can be easy questions, but then they can also give you some really, really difficult thinking questions as well. So we want you to try and get as many marks in this section here as you possibly can before you jump into the trig and the Euclidean geometry, which is where people seem to back the most. Okay, so before we get started on looking at some questions, I just want to do a brief recap on what's important in analytical geometry. Okay, so the first thing that's important is the equation of a circle when it is not centered at the origin. All right, so the equation of a circle not centered at the origin is x minus a squared plus y minus b squared equals r squared. Okay, so that is for a circle not centered at the origin. All right, what do the letters a and b represent? Does anybody know what do the letters A and B represent? They have a specific meaning, and we need to know what that is if we're going to be successful in this section. So what do the letters A and B represent? Go for it, Junior. So Itumeleng's also sent me an answer, which is correct. Junior, you're welcome to unmute your mic and talk to us if you'd like to.
Doesn't it represent the center?
It does. So it represents what specifically at the center, Junior?
Sort of like the point at the center.
Absolutely. Okay, so it's the coordinates at the center of the circle. Okay, so A and B change sign. So if we consider A and B as this, those are the coordinates at the center of the circle. What does the letter R represent? Cool. Diana, Fahim, Kanisa, good stuff. Okay, so that is the radius. Okay, so r squared is basically the length of the radius multiplied by itself. So the radius squared as well. Okay, good job, everybody. So that is the first thing that we need to talk about. The second thing that we need to talk about is when we take the gradient of a tangent and we multiply it by the gradient of a radius of a circle, because a radius is always perpendicular to a tangent, the product of their gradients is always going to equal -1. So this is because the radius is perpendicular to the tangent. Okay, so in other words, at the point of tangency, where a radius touches the center, or touches the circumference of the circle, and there's a tangent there, it's always going to be a 90-degree corner. All right. So in other words, if I just sort of try and draw this very quickly for you guys, there is a circle. Let's draw a radius. Let's do that. And then I'm going to draw another line. Okay, all right, so like so. All right, so what I'm saying to you here is if this little line over here is our radius and that line over there is our tangent, they're always going to meet at 90 degrees. Okay, so it's very important for us to know that if we want to calculate the gradient of either one of these two lines, the gradient of the tangent times the gradient of the radius is equal to -1. The other thing that's important for us to know is that tangents from the same point are equal. Do you remember that in Euclidean geometry? Tangents from the same point are equal. All right, so that's also something that is important for us to note. So if we have a right angle, what this means a lot of the time, and we don't necessarily need to have the line constructed. You can see in one of the questions this evening, we are actually allowed, if we want to connect 2 points together to make a right angle triangle. That's one of the things that we are allowed to do. We're not allowed to do constructions generally, but we can do a construction from one point to another to make a right angle triangle. So if we make triangles that are right angled, what theorem do we need to bear in mind? What do we need to be conscious of when we're talking about right angled triangles? There's a theorem that we've been doing since grade 8. That's it. Okay, so the theorem of Pythagoras. Okay, so that also comes into play in this. All right, and the theorem of Pythagoras tells us that the adjacent side squared plus the adjacent side squared is equal to the hypotenuse squared. So for any right angle triangle, let's just draw one over here. If this side is A and that side's B and that side's C, we would say that A squared plus B squared equals C squared. Okay, so we've got to know the theorem of Pythagoras as well. Let's go and have a look at the question that that I've given you. It says, in the diagram below, the circle with center M has the equation x minus 2 squared plus y plus 2 squared equals 17. A and B are points on the circle, and line AB has an equation y equals -1. So the reason that line AB has an equation y equals -1 is because it is a what sort of line? What sort of lines have an equation y equals? If they tell us that a line has an equation y equals, straight away, what sort of line is that going to be? Not straight is true, but more than straight. I want a word more than straight. Okay, because there we go, Inihle, well done. Okay, so horizontal, yes, Pabalo, it will be parallel to the x-axis. Quite right. Okay, so all lines that go y equals, all right, are horizontal lines. Okay, so in other words, like that. Okay, good stuff, everybody. So they've given us the equation of that line. Okay, so we know all the way along this line from A to B, y is equal to -1. Can you also see how we were talking about the equation of the circle in the beginning? So here's our equation over here. So if we now change the coordinates inside the brackets, that means that we've got the coordinates at the center, don't we? So if I was to ask you, what are the coordinates at the center of this circle? What would you tell me they are? So we're looking at the blue. What would you tell me are the coordinates at the center of the circle based on the information provided in the equation? Okay, so a lot of you are writing 2 and 2. Some people not so sure about which one should be positive and which one should be negative. Okay, they both have to change sign. Okay, so this one over here is going to become positive 2. This one over here is going to become negative 2. So if you said 2 and negative 2, then that is correct. Look at where the center of the circle is. In which quadrant is it? Exactly, Diana. It's in quadrant 4, isn't it? In the 4th quadrant. Absolutely. Yes, Farine. Okay, it's in the 4th quadrant. So we know that when we get into the 4th quadrant, X is positive and Y is negative. Okay, so everything has to make sense with what we already know to be true. All right, so we know that in the 4th quadrant, our X coordinate is positive and our Y coordinate is negative. What does this number here, 17, represent? What does 17 represent? Yes, Farine?
Can I please know why do they say it must be negative 2 and 2, the coordinates? How does it come to that for the letter M?
Okay, so no problem, Farine. It's because of the negative over here in the formula. Okay, so when you have a negative and a negative, then it's going to give you a positive. All right, so that's what's happening in the case of this one over here. All right, so because we subbed in negative 2, we would have ended up with this inside our bracket. So we would have had y minus negative 2. That would have been squared, and that's why we end up with y plus 2 squared. Okay, it's because of our formula.
Oh, I see. Thank you.
Oh, okay, no problem. Okay, all right. And of course, that formula is given to you on the formula sheet. But it's really nice if you know what it is and you don't have to keep going backwards and forwards. Absolutely. So a lot of people are saying radius. It is the radius, but remember it is the radius squared. Okay, so this 17 over here, remember the number on the right-hand side is r squared. So in this case here, r squared is 17. So if they wanted to know the length of the radius, I mean, they may not ask us that, but if we did have to work out the length of the radius, what would we need to do to 17? We would have to take the square root, quite right. Okay, so remember that the number on the right-hand side is the radius squared when it is given to you in this form. Okay. Good. All right. So now that we've analyzed the information that's been given to us, we also note that AE is a tangent to the circle. So it touches the circle in one place. Now we can set about trying to answer the questions. Well, we've actually already answered question 4.1.1. They've asked us to write down the coordinates at M. We've already been through that. So we know that the coordinates at the center of this particular circle are 2 and negative 2. And in this case, what they would do is they would give us a mark on each one, like so. Okay. Then in question 4.1.2, they ask us to calculate the coordinates of A and B. So A and B are points on the circle, and they both lie on the line y equals -1. So if they want the coordinates of A and B, don't we already know what the y coordinate at A is and what the y coordinate at B is? Do we know this? What's the y coordinate at A and B? Exactly, Diana. Okay, we know this. We know that it is -1. Okay, so it can't be 0 because we're not on the x-axis. All right, they told us, remember up here in yellow, that line AB, a horizontal line parallel to the x-axis, has equation y equals -1. So everywhere along that line, y is equal to -1. So that means we already know, as far as A and B are concerned, let's write over here, we don't know what the x is, but we do know that this is -1. And at B, we also don't know what the x is, but we know that that is -1. So how can we use what we've got to work out the missing x coordinates? How are we going to use this -1? What are we going to do with it? There we go. Okay, good, Diana. Okay, you're going to take that -1 and you're going to sub it into the circle equation. Absolutely. All right, so we're going to sub in and we're going to remove the y and we're going to make y equal to -1. All right, so now let's go ahead and go and do that. Let me just rub this off. And let's do 412 over here. All right, we know that we've got x minus 2 squared plus, and then we are replacing this y over here with -1 plus 2 squared equals 17. Now this has to end up being quadratic. All right, it has to end up being quadratic because we need two different solutions for x, one at A and one at B. Okay, remember that if we look at the diagram, we can see that B is like M. It's also in quadrant 4. So we are expecting B to be a number that's bigger than 2 at the very least, because at M, x is equal to 2. So we know that B has got to be bigger than 2. If we consider A is a point in the third quadrant where x is negative. So we are expecting a negative answer and we are expecting a positive answer that is bigger than 2. Right, so we're never ever working in the dark. If we understand what it is that we are doing, then there's always a reasonable expectation as far as our answer is concerned. And we have to look at our answers and look at the information that's been given and say, does this make sense? Is it reasonable? Right. When you FOIL out your brackets, okay, a common mistake that gets made at this point over here is that people forget about squaring a binomial and what that means, okay? When you are squaring a binomial, so x minus 2 squared, remember it means x minus 2 times x minus 2. Okay, so there has to be a middle term. You can't just square the first term. Thanks, Diana. You can't just square the first term and square the last term. So squaring your binomial gives us x squared minus 4x plus 4 plus minus 1 plus 2. So that would be 1 squared, which would be 1. And I'm going to bring the 17 over to the other side and I'm going to make it equal to 0 because I know it's going to be quadratic. So x squared minus 4x, and now I've got 4 plus 1 minus 17. So 5 take away 17 means that I am left with negative 12 equals 0. Okay, next step. Good, Diana. If you want to start looking at question 413, you're very welcome while I just work through this with everybody else. The next step, okay, is now to factorize in order to solve the quadratic. If you cannot factorize, don't stress, you can use the quadratic formula, but you have to show that you've subbed these numbers into the quadratic formula. Okay, so that's the rule. Hopefully for all of us, this is easy enough to factorize. So we're looking for two numbers. When we multiply them, it gives us negative 12, but the difference between the two is 4. So this would end up being x minus 6 times x plus 2. Is everybody happy with that? Good, well done, Orotila. Another thing that a lot of people forget here at this point, okay, is they leave off the equal 0. If there is an accuracy mark on this line, you're going to lose that mark if you leave off the equal 0. Remember, you are solving a quadratic equation. It must be equal to 0. Don't leave that off. All right, and as we've been told, either x is going to be equal to 6 or x is going to be equal to -2. So there we go. Our expectation has been met. One solution is a number that's bigger than 2. The other number is negative. So now we can go ahead and write down the coordinates at A. That would be -2 and -1. And the coordinates at B, which we now know would be 6 and -1. Everybody good with that? Okay, so that is out of 4 marks. So I suspect there must be a mark for this and a mark for this. There has to be a mark for subbing in. And my guess probably is that your mark would either be on this line, but more than likely on that one over there. Okay. All good. Oh, I'm glad to hear that. Brilliant. All right, so that means that we're ready to do the next question, 413. They want us to determine the equation of the tangent AE to the circle at A, all right? So here is tangent AE. There it is. And it's a tangent to the circle at A. Oh, excuse me, sorry. So when they want the equation of a tangent, what form does it take? Remember, this is now a diagonal line. So what is the equation of a tangent? What are we looking for? That's it. There we go, Diana. Thank you, Cleopatra. Yes, Cynthia, quite right. Okay, so they mean in the form y equals mx plus c. Right. What does the letter M represent? What does this M over here represent about the line? It's gradient. Excellent, everybody. Good stuff. What does the letter C over here represent about this tangent? Good, guys. Nice. Well done. The letter C represents its y-intercept. Beautiful. It is a constant. It is a constant number, but it is the y-intercept of the straight line. Okay, so in other words, where the line cuts the y-axis. So essentially what we were doing is that we're going to be working out what the y value is here at this point that I've just colored in green. Okay, so that's what they want from us. It's our job to calculate the m and the c. All right, we're going to write it in the form with y and x, but it's our job to calculate the m and the c. So now we're going to go back to the picture and we're going to say to ourselves, okay, how are we going to work out the gradient of this line? First of all, we've got the coordinates at A, don't we? All right, so we can go ahead and go and fill them in on the diagram if we want to. We know that the coordinates here are -2 and -1. At M, we know the coordinates are 2 and -2, and at B, we know the coordinates are 6 and -1. The problem is using gradient formula, exactly, Diana. Okay, so using gradient formula isn't going to help us in this case because we don't have the coordinates at E. Right, we don't have the coordinates at E, so we can't use y2 minus y1 over x2 minus x1. So that's why I was trying to say to you, what other ways do we know how to calculate the gradient of a line? All right, and this is exactly it, which is Diana has just pointed out. Remember, the gradient of the tangent times the gradient of the radius is equal to -1. Never, ever, ever forget about that. Okay. Intercausal, how is midpoint going to help you calculate a gradient? How is midpoint going to help you calculate a gradient? Can it help you? I mean, or are you saying that this green dot represents the midpoint? Well, we don't know that. And as it is, we don't know what the coordinates are at this point in any event. Okay. All right. So Bonolo, what I'm saying is this. Okay. So it was the things that we were talking about at the very beginning. Okay. When you have got two gradients that are multiplied together to give you -1, all right, it means that the two lines are perpendicular to one another, and the radius is always perpendicular to a tangent. Right, so the product of their gradients always equals -1. Very, very important piece of information. Okay, so the letter M stands for gradient. Gradient of the tangent times the gradient of the radius always gives us -1. Oops, oopsie, I put the negative. Okay, always gives us -1. So what I'm saying is we cannot work out the gradient of AE because we do not have the coordinates at E. So we cannot use gradient formula. So there's got to be another way of doing it. And this is the way that we would do it in this case. All right. Oh, wow. Some of you have already done the answer. Yes. Good. All right. Well done. Let's go and have a look if you guys are indeed correct. Okay. So in 413, we have the coordinates at the circle and we have the coordinates at the center. That means that we can calculate the gradient of the radius. Okay, so in other words, line AM is the radius. We can calculate the gradient of the radius using our traditional gradient formula. So in other words, we would end up with change in y, so -2 minus -1 over change in x. So 2 minus -2. So the gradient of the radius ends up being -2 plus 1, which is -1 over 4. So those of you that got that, well done. That's perfect. Hang on a second. Let me just move this down. Okay. So now we would write the gradient of the tangent times the gradient of the radius gives us -1. We know we want the gradient of the tangent because that is the m in our y equals mx plus c over here. So we're going to sub in -1 over 4 equals -1. And what we can do is divide both sides by -1 over 4. And that means that the gradient of our tangent is going to end up being +4. So well done to those of you that got that correct. Okay, so the gradient of the tangent is 4. Now we can go and take that and sub it into y equals mx plus c, because we know that the gradient is 4. It's our job to then work out what the c is. What point can we sub in? Zinhle, it isn't a problem if you use the diameter instead of the radius. The only thing is that you don't know what the coordinates are on the other side over here. Because remember, a diameter goes from one side of the circle through the center to the other. Okay, so a diameter is also perpendicular to a tangent. Okay, so that would also be true. All right, yes. So I can't use the gradient of AB. No. Because AB is not a diameter. Okay, it's just a chord. It doesn't go through the center of the circle. Okay, so AB is not perpendicular to AE. Does that make sense, Ntokozo? Okay, so Joshua, how did I get 4? All right, so at this point over here, Joshua, where I'm highlighting in yellow, this is an equation. All right, so I'm solving for this guy, for the gradient of the tangent. So the opposite of times is divide. So divide both sides by 1 over 4. Take -1 on your calculator and divide it by sorry, take minus 1 and divide it by negative 1 over 4, and you will see that the answer is 4. Okay, so that's where it comes from. Now, as the others were saying, right, if we go back and we have a look at the diagram, the tangent goes through A. So the only pair of coordinates that we know that lies on this line are the coordinates at A, which are -2 and -1. So now we are going to sub that in. All right, we're going to sub in A, -2, -1. All right, and we would now end up with, let me just move this down even more. We're going to end up putting -1 over here, 4 over there, -2 over here. So this gives us -1 is equal to -8 plus C. So that means that C is going to be equal to -1 plus 8. And that's why C is equal to 7, as so many of you said. All right, so those of you who have got Y equals 4x plus 7, 100% correct. Okay, well done. That's lovely. Okay, good stuff, everybody. How are we all feeling so far? Let's just check in with you guys. Are we okay? Is everything making sense? Want to send us an emoji? Oh, lovely, Papalo. Cool, Lolita. Good, nice, Nick. Cool, Candace. Okay, it's going good. Oh, I'm fine, thank you, Zintley. Yeah, you just got to keep practicing. Okay, so it's important to first understand and then go and practice afterwards. Okay. All right, good job, everybody. This is great. All right, let's do the next question. So that is 4.1.4. We're going to calculate the coordinates of E if BE is a tangent drawn through B and has the equation y equals -4x plus 23. Just 1 second. I'm just super thirsty, so I'm just having a quick drink. So what they are telling us here, Matrix, is that we have a line drawn from E to B. All right, and this line, let's just move it up there. So there it is. I've drawn it in. Whether it's there or not, it really doesn't matter. Okay, so it has an equation. The equation of this line, it is the line y equals, let's just write it here, y equals -4x plus 23. No problem, Bridget. Welcome, welcome. What they want us to do is they want us to calculate the coordinates at E. So everything that we do helps us to do the next thing, all right? So the fact that we've just got the equation of AE is really important for us to be able to answer question 4.1.4. What does point E represent? How would you exactly spare? Exactly. Okay, so we can use simultaneous equations. Quite right. Okay, so E is a point of intersection. Okay, and that's exactly what we would do, as Spare had suggested. So we are going to take our equation, 4x plus 7, because remember that's what we worked out down here, and we're going to make it equal to what they gave us, -4x plus 23. And now we need to solve for the x coordinate at E. Okay. Good, Farine. Okay, so now we're going to take this over to the other side. So this is going to give us 4x plus 4x. On this side, we've got 23 take away 7. So this gives us 8x is equal to 16 and x is equal to 2. Okay, so a couple of you have messaged me already and told me that. Wonderful, good stuff. Now I can use either one of my two equations. Okay, well done, Deanna, that's right. And you can sub it into the minus 4x equation, or you can sub it into the 4x plus 7 equation. It's not going to matter because at E, they have the same y as well. Okay. So you would just pick one, anyone. Choice is yours. I'm going to go with 4 times 2 plus 7. Sorry, my 2's are terrible. So that's going to give us 15. Okay, 8 plus 7 is 15. And then the last thing that I want to do is just make sure that I've answered the question. So I'm just going to go back, have a look, calculate the coordinates of E. So I just want to give my answer as a coordinate pair. So in this case, 2 and 15. It must be a point in the first quadrant. If I go and have a look at the diagram, it seems reasonable that those are my coordinates. Okay, good job, everybody. That was really, really, really well done. I hope you're all feeling good and it's making sense. Lovely, Farine, that's perfect. Okay, 100%. Okay, so that gets us what? 6, 10, this is 13 marks. Okay, so that is a nice chunk of question number 4. Unless there are any questions about what we've just done, I'd like to move on to the next question. Is that okay? We're all ready to move on? Okay. So let's just, cool, nice. All right, everybody. So let's just move this down a bit and make it a little bit bigger. So this question is a little bit more difficult, okay? Not much, but just a bit, okay? First of all, what I'm going to do is I'm just going to move this over to the side, and I'm going to take the questions and I'm going to put them over here so that we can see both the questions and the diagram at the same time. All right, so this comes out of a national paper. So this is the sort of thing that we can certainly expect to get in finals. They've told us that M is the center of the large circle. All right, so here's M over here. M is in quadrant. M is in quadrant. Two. Good. Okay, so it has a negative X and a positive Y. Okay, good stuff, everybody. Okay, let's just have a look. There was a question here. So Itumeleng, you're asking, ma'am, how would you find the coordinates if you were only given coordinates instead of equations? In relation to what, Itumeleng, are you asking? Are you talking about the previous question where we were calculating the coordinates at E?
Yes. Yeah, he meant in relation to the coordinates of E.
I don't 100% understand what he's asking, because if they're asking you for the coordinates of E, they wouldn't give you the coordinates at E. So if they ask you for the coordinates at any point, it's always going to be a simultaneous solution. It just depends on a simultaneous solution between what. So either it could be a point on the circle, so it could be a simultaneous solution between the radius and the circle, or it could be a simultaneous solution between a radius and a tangent, or it could be a tangent and a circle. Any one of those three you could use to do a simultaneous solution to find coordinates. I hope that answers your question, Itumeleng. All right, now, Deanna, you also asked something. Let's just go back in here and have a look.
Okay,
So you
ma'am.
already had the coordinates of A and B, but you had to find the coord. Okay, so Itumeleng, we've got that. We've got the coordinates of A and B.
Ma'am, I just want
So
to
you
also,
mean if we didn't have the equations, do you mean if we didn't have the equations of the lines, Itumeleng? Is that what you mean? Okay, so then it would have to be something that I've said to you. So in other words, Itumeleng, we wouldn't be able to work out the coordinates at E if there was no relationship between E and the circle. It would either need to be a point of intersection of two tangents, or a point of intersection between a tangent and a radius, or something like that. We can't just use the coordinates at A and B to work out what the coordinates at E are. We also cannot make the assumption that E is in the middle, that E is in the same vertical line as M. I mean, it may work out that it is, and it does in this case, but it doesn't necessarily mean that it's going to be, because E could be, you know, moved to the left or moved to the right. Okay, it just so happens that it is, but I wonder, Itumeleng, if you couldn't maybe use, if they told you that E and M were in the same vertical line, then at least you would know that at E, M was equal to 2. So I'm just trying to think if you could do the theorem of, no, Pythagoras is not going to help you. Yeah, no, you would need more information. Okay, Itumeleng. Okay, Diana, go for it.
okay, ma'am.
Mhm.
They say the smaller circle, so the point at O is 0, 0. So A and B will then both be 0. But R, because MS also touches the circumference at S, does that not equal then MN? Oh, we know it doesn't. MN does not touch the circumference.
No, N is yeah. So N is a point
Yeah.
outside the circle. But you're quite right. What I really love about what you've said, Diana, okay, is that you've said that the equation of the smaller circle has to be in the form x squared plus y squared equals r squared. Now, those are circles that are centered at the origin, isn't it?
I don't know.
It
I think
is.
so.
Yep, it is.
Okay, it is.
Okay, so circles that are not centered at the origin take the form x minus a squared plus y minus b squared equals r squared. And circles that are centered at the origin take the form x squared plus y squared equals r squared, because the coordinates at the center are 0. So if we take x minus 0 squared plus y minus 0 squared equals r squared, we would get x squared plus y squared equals r squared. Okay, so, all right, so equations that have their circle at the center, at the origin, take the form x squared plus y squared equals r squared. So it's your job to then work out the value of r. That's what determine the equation of a small circle means. It's actually asking you to calculate the value of r squared. That's what it means. Yes.
Wait, how much box is it? Since that oh, okay, never mind. No, I'm just like who's muting me and unmuting me the whole time? Ma'am,
I don't know, it's not me.
I'm just a little bit puzzled because if I were to do this, I would take MN and put it on delta X to try and find the gradient. But we don't have the y value by n.
Okay, so here, Diana, what they're asking you for the equation of the small circle. That's this over here that's in green. So what they want from you is a value for r squared. That's what they want from you. So you know an x and a y on the circumference. Here's your x, here's your y. So you're going to sub them in here. So you're going to sub in your x here. So the minus 3 is going to go here, and you're going to square it. And then y, which is 4, is going to go there, and you're going to square it, and that's going to be equal to r squared. So that's going to give you 9 plus 16, which is going to give you 25. Okay, you don't have to work out r. Remember, on the right-hand side, it's always r squared. So the equation of this small circle is x squared plus y squared equals 25.
Okay.
Okay, that's what they want from you. All right, so 1 mark for subbing in and 1 mark for the answer. Okay, does that make sense to everybody else? How does everybody else feel about that? Making sense. Thanks, Cleopatra. Junior's happy. Spare, okay, good, thank you. Kamgelo, thanks. Richardsa, thank you. Good, Farine, good, Candace. Nice. All right. And Tokozo, you're saying, ma'am, why will you use -3 and 4 to get r squared again? No problem. So because we want r squared, we want to determine the value of r squared in Tokozo, it means that we need to know what x and y are so that r is the only variable that we are solving for. And m is a point on the smaller circle. So that means that we can sub in this x and this y in order to work out what the r squared is going to be. Yes, Atronetse, lovely. Okay, very good. Oh, sorry, there just was another question there. Hang on a second. Zintle. So we can use points that lie in the circumference. Absolutely, Zintle. Any point that lies on the circumference. Okay, because that is how, I mean, if somebody said to you, what is a circle? How would you describe it? What is a circle? Isn't this interesting? Hey, we always talk about these things and we learn about them, and then if we actually have to describe what it is, it's actually quite difficult for us. All right, so a circle is 2 things. All right, the first thing is that there is a point in the center, and every other point is the same distance from that central point. Every other point is the same distance from that point in the center. Okay, and that's your circumference. So yes, simply any point that lies on the circumference can be used as an x and y coordinate that can be subbed in. Okay, whether the circle is centered at the origin or not centered at the origin. Okay, so Junior, would you be wrong if you were to use distance formula? Well, no, because I mean, what we're actually doing is distance formula. So if you wanted to do distance formula between M and O, not a problem. Okay, would be a little bit longer, but not a problem. Okay, and you would find you'd get exactly the same answer as what I've got. It was, as I say, it would just take you a few more steps. Okay. All right, I don't know if we're going to manage to finish this question today, but anyway, we can always come back to circle analytical geometry. If you guys are enjoying this and you want to do more of it, then you can tell me, I don't mind. The next thing that they want from us is the equation of the circle centered at M in the form x minus a squared plus y minus b squared equals r squared. Oh yes, Nick, I remember your question from Tuesday. I haven't forgotten. Yeah, I hope we're going to have time to do that. Oh, otherwise, Nick, are you coming to were you at the boot camp? No, okay, all right, fine, not a problem. Okay, let me just get through this and then we'll see if we can come back to that particular question. Okay, all right, so 4.2, determine the equation of the circle centered M in the form x minus a squared plus y minus b squared equals r squared. So that's why I mentioned this at the very beginning, and I said we need to know what each of these letters represents. So x and y are any x and y point that lies on the circumference. A and B, when we change their signs, are the coordinates at the center, which we've got. Remember, M is the center of the bigger circle. And r squared, what's on the right-hand side, is the radius squared. Okay, so if we understand all of that, we can go and sub in the center of the circle. So in 4.2, what should I write? What's the first thing I should write on the page? Yes, it's online, Sinisipo. So we do it on it's a matric boot camp, and we're doing it for 2 hours every Saturday afternoon. Okay. Until you guys write finals. Okay, so what's the first thing that we're going to write here, guys? Okay, so M is the center of the largest circle. Okay, so we want to go and we want to sub in. Good, Zintle. Nice. Okay, so we're going to write here x plus 3 squared plus y minus 4 squared equals r squared. Is everybody happy with that? So I am subbing in the coordinates at the center. Remember, they have to change their signs. Okay, so that's why the 3 is a plus and the 4 is a minus. If they want us to find the equation of the circle, what are they really asking us to calculate now? They want r squared from us. Okay, so if we want to calculate r squared, it means that we need to know a point that we can sub in, because we can't calculate r squared if we don't have a point to sub in over here, unless, of course, there's another way that we can do it. So now we're going to go and have a look at the diagram. Can we use the coordinates at t? Okay. Do we know anything about t? What have they told us up here? So center 0, 0. They've told us that nt is a tangent to the circle at t, with nt parallel to the y-axis. Okay. nm is a tangent to the smaller circle at M, with MOS a diameter. Okay, can we use O? Good question, Amal. Does the larger circle go through the origin? The larger circle does not pass through the origin, so we cannot use O. Farine, you've got your hand up. You're welcome to unmute and ask.
Ma'am, I want to know something. For the equation of a circle, do we have to square both brackets? Like for x minus a squared, we put in the x-intercept, and for the y.
Yes, so you've got to square both brackets. Okay, so it's always x minus a in brackets squared plus y minus b in brackets squared equals r squared, yes.
Thank you, ma'am.
Okay, no problem. No problem. So somebody said something about t, all right, and you're on the right track, okay? Junior. Junior says the coordinates at t are -11 and 4, okay? How did you work that out, Junior? You're right, but I want to know what you did. Can you unmute and talk to us? So yeah, but the distance from M to T is going to give us R squared. You're quite right. So Junior, I don't know if you are, yeah, intercausal, absolutely. We know how he got the X, right? Because T and N are in the same vertical line. So they have to share the same X coordinate. How did he work out that the corresponding Y, oh, it's just refusing to unmute. Nelly, can you help him? Please.
Who wants to speak?
So it's Junior.
Oh, Junior.
He's going to try and explain to us how he got the y coordinate at t to the 4.
Okay, can you hear me, ma'am?
We can hear you.
Okay, isn't that the question tells us that t is parallel to the y-axis. This tells us that t is like, or is the point on a straight line.
Yes.
And then we have like it's a sign, I think, that x, like that n and t have the same. x-axis. I want the same x-axis, which is -11.
Yes, quite right. Okay, so they are in the same vertical line, so they
So
have
that-
to share the same x, which is perfect. And then
So-
you're on the right track here. So in other words, what you're saying is because this line over here is parallel to the y-axis. That's really important in this case. If we were to draw a diameter, let's just grab a different color, and we were to draw a diameter from T through M over there, all right? Because this line over here is parallel to the y-axis, it means that it would have to be at a right angle to the line coming through the center, because all tangents are perpendicular to the radii. All right, so that means that as far as T is concerned, it has to be in the same horizontal line as M. Okay, so that's where he got it from. Okay, so it has to be, the man is smart, isn't he? He certainly is. Okay, all right, so let's now go back and go and sub in this point. So knowing that the coordinates at T were -11 and 4 was critical. What we're going to do is we're going to go and sub in the X, which is -11 plus 3 squared. We're going to sub in the Y, which was 4, and we're going to work out what R squared is equal to. All right, now I just want to check on the chat. Okay, Zinhle, no problem. Hold on a second. Okay. And we would then be able to work out the value of R squared. Okay, so I just see there's a couple of people in the chat asking me to go back and just re-explain things. I feel so bad because we have now actually run out of time, and I need to go to the next lesson. Nick, I promise you I will not forget about your question, okay? I promise, we will do this together. So x plus 3 squared, y minus 4 squared, it would be equal to 64. So just very quickly, I do have to go, unfortunately. T and N are in the same vertical line, so they share the same x coordinate. T and M have to be in the same horizontal line, okay, because T is parallel to the y-axis. So that means that if a line comes through the center to T at the circle, it has to be perpendicular. Right, so these two have to be at right angles to one another, which means that T passes through the same horizontal line. Okay, so it has the same Y value. Okay, so you're going to go and sub the X in here, the Y in there, so that you can work out what the R squared is. Okay, do